and this might be like important material. So let me record it for you guys, and let me also turn on captions, just so if I'm talking too fast, you can always look at the captions just to see what I said before, right? So again, like there are like many problems, right? Thousands, 10,000, 100,000. There's a lot of problems, right? In the world of algorithmic programming, and they're just made by amazing, very smart people, right? And it's impossible for you to memorize the solution to every single problem. And even if you did, well, there's always going to be new problems that are made, right? It's good to, I guess, like memorize, I guess, like some basic things, like there's some basic algorithms that you have to memorize, especially like binary search, or if you get into deeper things, there's some like recursion, or maybe some like search functions, like there's like basics that you have to memorize. But at the end of the day, problems, you can make a variation of a problem like infinitely. There's infinite variations to a problem, right? So it's not very, I guess, it's not very practical to memorize how to the exact code for every single problem, right? And that was what I was trying to get you guys to, I guess understand and maybe build that muscle memory is I want you guys to understand the intuition behind a problem, right? How you can approach a problem, how you can solve the problem, right? Not just the actual code for the problem, but how you can go from knowing, nothing to like getting the entire solution, right? And that is, I guess, the most important skill of problem solving, right? Because problem solving is basically the idea of, hey, I have a problem, right? I want to solve the problem, and how I'm gonna take steps to tackle and solve the problem, right? And I just really want you guys to be able to have that intuition, and not only for coding, right? A lot of times, right, like you could memorize knowledge, right? Of course, like knowing what binary search does, or knowing if you guys want to continue knowing what recursion does, knowing how to code, what a for loop does, what a variable, what a list does, right? Things like that. That's of course important to remember and memorize. But at the end of the day, it's really important that you guys build the intuition to solve the problems, right? You're not gonna it's basically going to be very unlikely that you're going to like look at a problem in the future and be like, okay, well, I memorized the solution already, so I'm just going to do it, right? Unless you're redoing a problem. But like if it's like a new problem, then it'll be more like valuable for you guys to learn the problem solving skills than rather than just the entire solution, the code of the solution, right? How to write it, right? And well, not like how to write it, but mostly just like like the exact solution or something, right? I want you guys to learn how to solve the problem, right? That's very important. And that was what module two was kind of about, right? Module two, I just really wanted you guys, right, to build the intuition, right? I try to teach you guys how I go from knowing nothing about a problem to understanding the whole solution, right? And that's what we're gonna go over today. And we're also gonna go over, we'll learn about one, I guess, base, I guess, like thing that base algorithm that you have to memorize probably, or not, and make sure you understand. And also one thing very important is when you are learning something, it's very important that you understand what you learn and not just like memorize what you learn, right? Like for example, binary search, right? I want you guys to understand why binary search works, right? Not just the code for binary search, right? Because binary search problems will not just be like the binary search code, right? There'll be variations to the binary search code that you will have to memorize. Like maybe calculating mid will be different, or maybe your bounds might like move a little differently, right? But at the end of the day, it's about how you can it's about your understanding of binary search. You know how binary search works, right? And that is the most important thing that I want you guys to get from this class, right? Is how things like work, right? You understand how things work, and not just like what the code is for binary search or something like that, right? Because except for the one binary search problem, like the base binary search problem, there's going to be many variations to binary search problems. There's going to be many variations to a lot of the problems that we did, right? And that is one thing, again, you cannot just memorize the code for a problem. You have to be able to understand why the solution works, right? And understand how to get from knowing nothing to the solution, right? I really want you guys are still young, right? Because you guys are still learning, but I just want you guys to give you like a heads up or something, right? I want you guys to be able to understand how to solve problems, right? Not just memorize them, but how to solve them, right? That is very important. And if you guys want to continue on the algorithmic path, that is one thing that you guys should, I guess, keep in mind is to not just memorize the problem, but to understand it, right? It's very important. And so just that was just a big tangent and very important, but it's just something that I just wanted to say before we moved on. So today, all we're gonna do is just review everything, right? review the intuition and the problem solving skills that we learned from this class, right? And also, I guess I want you guys to make sure that you understand why binary search works, right? So let's just quickly get started, right? Probably gonna spend the first half of the class, maybe for like 10, 15 minutes. We're just gonna talk about how we're gonna solve a problem, right? How you can go from knowing nothing, right, to solving the entire problem. Right? And then after we're just gonna talk about how binary search works. And I'm still like thinking if I should give you guys not really a final, but maybe it's just like a final problem for you guys to do. I could post it, but I guess I just won't grade it if you guys want to, or if you guys really want me to, give you guys some feedback or whatever, you guys can just let me know and I'll try to do that. Okay. But mostly from this class, right? I guess module two wasn't just about, memorizing the 15, 20 problems we did, right? It's about getting, building, starting to build your intuition how to solve the problems, right? And computer science is it's very beautiful like that because every day you get to solve a new problem, right? You get to tackle a new problem every single day. And if you're curious and you like doing that, of course gonna be very fun for you guys, right? And you guys are of course very smart students, right? So, I understand it's not easy, right? Problems like problem solving, it's not easy. And I know it can get frustrating sometimes. And I know because I had to go through the same thing you're going to, right? I was frustrated, I was really angry if I couldn't solve a problem. And after like, 2, 3 hours of trying a problem, I couldn't even solve it. And it's very frustrating. But at the end of the day, it's about, the learning process, right? The learning process is very important. And just, I hope you guys just don't feel discouraged, right? Because, feeling frustrated, it's probably going to happen, unfortunately, right? It's hard to, when you're solving a problem, you put a lot of effort into it and just can't get it. It's, of course, very frustrating and very hard. But please don't feel discouraged, right? You guys are very smart students, and I really believe that you guys can do great things, right? You guys are awesome, right? And the fact that you're even just taking this class, right? This class is outside of your school. I guess it's like schoolwork. So you guys are already amazing students, and just don't feel discouraged, okay? Whatever you do in the future, and even if it's coding, if it's not coding, just don't feel discouraged, okay? Just keep on going, and if you guys continue to go down the algorithm path, right? And I know you guys will do very well. Okay, so let's just go over how we solve problems today, right? So let's let's not work together on a problem actually, because this is I feel like we did a problem very similar to this in the past, right? And sometimes this is also like a very nice tip because sometimes you're gonna have to work with like strings and um like letters in the alphabet. So if you guys ever just want to refer to these slides and just copy this alphabet list, you guys can. So it's just like a template, I guess. So it might help you with some problems, and you don't have to make it yourself, right? So this we don't really have to go over this, I just want to go over with you guys the problem solving skills, right? And I don't think we're gonna have enough time to go through this problem and then go over everything, but let's just review what we learned in the past, right? And since this is the last class, right, and also there's another this problem, but this is actually from what I remember, this is a medium problem. So I never assigned you guys medium problems. Actually, I'm not quite sure. Oh, this is what, oh, sorry, this is not a medium. This is one of the, I guess, how do you say, the harder, easy problem. So you guys do want to, one of the harder, easy problems. And leak code, the easy problems, they're not, I guess, they're labeled easy because in terms of all the other problems, they're one of the easier ones, right? And for now, when you guys are tackling easy problems, maybe you want to challenge yourself to medium problems or even challenge yourself to hard problems, right? There's, just right now as you're learning, try to go with the easy, medium problems. And once you get much better, right, better and better, you guys can start doing harder problems, right? So, this is probably one of the harder easy problems I would say in my opinion because you can see that the code, right, my code is not the simplest code but it is the most straightforward way, right? So it's kind of long, you're like, oh wow, that's scary. Right? So we're not gonna go over these, I guess, like these things, but I just want you guys, I guess, to maybe work on these problems after this, right? If you guys really just want to get better at coding, or you really want to, learn and go down the path of algorithm programming, it's an awesome way to go. And you're gonna learn a lot. You're gonna get very smart, very good. Right? You guys are already smart, but you can get much smarter from algorithm programming, right? So I just think that if you guys want to, you can always just tackle these problems, see what you can do, and the solutions are always there, right? And if you guys have any questions, just let me know. Okay, I can try to help you guys out. But today, right, we're not going to go over these problems. Okay, so let me just quickly congratulate you guys actually for one. So this actually wasn't a 12-week course. I mistyped. Should have been like it's been, I kind of lost count. It's kind of like a 20-week course, right? Because it was consecutive. We learned module one and we learned module two, right? So we learned a lot, right? So like you guys went from knowing basically nothing about coding to, knowing being able to even solve problems now, right? Being able to apply your coding. And I feel like you guys have learned a lot already. You guys have come a very, very long way. But I'm really proud of you guys from working hard, trying and solving problems. If you're frustrated, I'm sorry, but that's just sometimes it will happen. But I'm really proud for you guys for overcoming those challenges when you feel frustrated, when you couldn't solve a problem, and for you guys to at least try, right? I really hope that you guys at least tried for every single problem, spend 30 minutes on homework or even more if you wanted to, and try the problems when I gave you the time in class, right? So like I'm really proud of you guys, right? You guys did a lot of amazing work, right? These past many, many weeks, right? We started this thing in the summer, basically, right? And now, it's 2025 already. It's almost February, right? So you guys did a lot of amazing work, right? And I know time flies, but I know you guys learned a lot of stuff, right? And just really proud of you guys. I know that you guys will do amazing things as you get older. You guys are still, still young, still small, right? I mean, I can't be talking. I'm also like, I'm only a junior in high school. So, but you guys are still like, you guys are amazing. You guys, of course, will go far. And do amazing things. I just want you guys to know, just keep on pushing. Don't feel discouraged, okay? And you know, after this, let's just go over some review, right? If you guys ever need to, like, I guess maybe forgot something, where you can always look back at these slides, or you can always look back at this recording. You can always look back at this class. I don't think the class should be deleted anytime soon, but if it is, I just recommend you guys just download all the recordings, right? Because I only recorded classes where we learn new material, right? Like I didn't record a class where we had like a problem and there's like a 30-minute like pause between the video. We just did nothing, right? Or not really, we did nothing. Like hopefully you guys were solving problems during that time, right? Like trying the problems for yourself. Um, I recorded most of the class where trying new material, like when we did pseudocode, when we did problem solving. This class will be recorded just so you can have everything that we learned in module 2 in one place, right? So, you know, congratulations, right? You guys finished a very long course. You guys should be proud of yourself. You guys all did an amazing job, right? I know that the problems could be hard sometimes, but you guys did amazing. Okay. So don't worry about, not being able to solve some problems. You guys did amazing. You guys are still learning, right? You guys have, still much learned, but you guys already know a lot, right? So let's just before I guess we end this whole class, I guess, because this class only had two modules, right? So let's just go over everything that we learned, right? All the things that we learned in module 2, right? The recordings posted about module 1 in the Google Classroom, so you don't need to worry about that. But just so we can, I guess, just so we can review everything that we learned, right? Let's just start. Okay, let's really start. And I think I need to turn my volume a little higher. So you guys can let me, if you guys have any questions, just type in the chat, everything like that. Just let me know. Okay, so first, the most important thing in this class is the problem solving techniques, right? I'm gonna go over it just one last time, just so you guys can just have it all in one place in one recording. If you guys want to review, this is the problem solving technique, right? So 4 steps. That's it. Right? This technique only has 4 steps, and we're gonna go over all of them. Right? We talked about this before, but just so we can get you guys just to review and just remember everything. Right? So number one, right? What step 1 out of 4? We need to read the problem very, very carefully, right? And why do we do that? Well, you guys remember from let me just let some people in. So you guys remember when we were solving problems, right? The problem statement, right? The ones I gave you were maybe, 1, 2 sentences long, right? Maybe even longer problems will be, 3, 4 sentences long, even like 2, 3 paragraphs. And not to scare you guys, but the harder problems might be very long, right? So, but the reason you want to read the problem very carefully is you want to make sure you're solving the right problem, right? Because you could be reading, some problem, you go read, and then you might miss a phrase, right? Maybe the phrase is, we want to, I don't know, like reverse the list at the end of the problem or something like that, right? Or, divide the answer by 2 at the end for some reason, right? So there could be like a lot of, I guess, ways you can misunderstand the problem, right? And that might be scary when you're solving a problem because at the end of the day, right, if you're gonna spend so much time coming up with a solution, doing steps 2, 3, and 4, right, you don't want to be solving the wrong problem, right? So that's one of like the worst, like, I guess, situations you can get yourself in is you're solving the wrong problem, right? Sorry, but you're solving the wrong problem, right? And that is really bad because then you're just wasting your time. Right? You're not solving what the problem wants you to do, right? It's kind of like like someone asks you to do something, like someone asks you to get them like an apple or something, you give them like a banana, right? It's like it's the wrong problem, right? So you really want to make sure you want to do the right problem, right? And I think there's no, let me see what's in the chat. Yeah, like you know yeah, exactly. You want to be able to solve like the right problem, right? And that is very important, right? And even so, and like not to put any blame on you guys or anything, you're so amazing students, but sometimes I did, you guys might have made a mistake, right? Everyone makes mistakes, but you guys might have made a mistake and be like, oh wait, I read the wrong problem, right? Or I might have skipped over this while reading the problem, and then you guys might have like asked me a question about it. But luckily, like since I know the problem, I can point out what you're missing. But later on, when you're solving things by yourself, right? If you understand the problem wrong, right, you're gonna be solving the wrong problem, right? Because I won't be there always for you guys just to point out, you guys missed out on this, you guys missed out on this, you guys misunderstood this, like but I feel like just make sure you read the problem carefully, right? Make sure you read the problem statement, right? Make sure you understand the problem statement very well, right? And then read the constraints to the problem as well. Because leak code has some like constraints as well, and they have the problem statement and they have the constraints right after. Right? So like read the constraints on the bottom of the page as well. They give you good information too. But most importantly, the problem statement makes sure you understand everything, right? And sometimes, like for example, I remember like one string problem we did. It was like you guys, it was like the letters in like a sentence can only be like letters A to Z and numbers 0 to 9. It was like you have to rearrange the sentence, right? So you guys were like, hey, wait, can the sentence have like other symbols other than A to Z or something? Right? Can like how can the sentence be made? Right? And that's what they said in the problem, right? Because it literally said the sentence can be made with only letters A to Z, right? So and number 0 to 9, but the number 0 to 9 like indicated the index, like where the word was supposed to be in the sentence, right? So it's very important for you guys to see, oh, when you read the problem, you're like, oh, wait, the sentence can only be made from letters A to Z, right? It won't have like a random, question mark or like some like random dollar sign or something. Like it won't be like random letters, right? It'll only be letters A to Z. And you get that information only through when you read the problem very carefully, right? You understand the entire problem, right? You're not solving the wrong problem. You don't miss anything from the problem statement that makes you extra confused, right? You want to be able to understand the problem because that's how you start solving the problem, right? For everything, whenever you do, make sure you read the directions or the problem carefully, very carefully, right? And there's always, keywords that might signal an algorithm. Like sometimes, like LeetCode likes to give you like a hint when it says like, it's like the list is sorted. You might think, hey, that might be a binary search problem, right? So like just very some keywords that you guys will build as you guys do more problems, but just some keywords that you guys, might want to keep track of, make sure you understand the problem carefully. That is step one. Okay, step one, make sure you read the problem very, very carefully. Okay, very carefully. And step two, right? Step two. And you can see that there's a problem statement. There's, some test cases that they give to you for free, very awesome, and some constraints, right? Step one is reading the test case, reading the problem statement and reading the constraints, right? In the middle, so they call test cases, right? Test cases are like the example one, example two in LeetCode, right? And you want to look at every single test case given to you, right? Then like number two is where you validate your understanding of the problem, right? You make sure that you understood the problem correctly, right? That is step two, right? Step two, reading the test cases. I want to, make sure that I'm understanding the problem fully, completely, right? And you know, and by now, right, it's probably unlikely that you guys have a solution, right? Like a very clear cut solution in your mind, right? And this is when you want to start looking at test cases, like that aren't in the problem. Well, and how do you look at test cases that aren't in the problem? Now you understood the problem. If you understand the problem, you should be able to make your own test cases, right? Like for example, like there was like a string like a string problem we did like maybe a week or two ago, where it was like A, and like there'd be like a number next to it, right? Like A B, right? There'll be like a number next to it, and the riddle sentence will be like, so A was the first letter, and like A B is like the second word, right? So like once you understand like the problem, you should be able to make your own test cases, right? You should be able to make your own test cases, right? And sometimes test cases might get tedious, but it's very important for you guys to make test cases so you could find a solution, right? The goal is for you guys to find a solution, right? By making test cases. If you guys can already use the examples they give to you to make test cases, great, awesome, right? You already have the problem. You don't have to do, I guess, like step 2.5, right? So, but step two is, I guess, like two steps in step two, right? You want to look at all the test cases that are given to you, right? And if you don't have a clear-cut solution in your mind yet, make your own test cases and try to find a solution from there, right? That is, I guess, step two might be the hardest, right? The hardest of the bunch because you have to find the solution, right? And when you're finding the solution, you remember you want to find a solution that kind of mimics code. Because remember, code can only be run iteratively, one step at a time, right? Your brain is very smart, right? Your brain is going to be smarter than code, right? But code can just like do more steps, like step by step very quickly. But your brain is able to do multiple steps at once, and that is one thing when you're doing problems. Try not to like let your brain get too far ahead, right? You want to keep your brain, at the same step-by-step level, right? Only when you're solving problems. When you're thinking about something, doing a solution, a test, you could always, think multiple parts, right? Multiple things simultaneously. But the most important thing when you're doing a problem and finding a solution, right? It is very important for you guys to be able to find a solution step by step, right? Step by step, very, very important, right? Because a computer can't do anything like two steps at a time or three steps at a time. It can only go step by step, right? So make sure that your solution is feasible with code, right? It's possible to make with code, right? Step by step. Okay. So number two, right? First, look at all the test cases they give to you, right? And then second, if you don't have a solution in your mind yet, make your own test cases, right? Because if you understand the problem, you should be able to make your own test cases, right? That's just kind of how it works. And if you guys, aren't able to make your own test cases, make sure you understand the problem carefully. Right? So just go back to step one, try again. But I know you guys can. Yes, it will do amazing for steps one and steps two. Steps two. Okay, and and on paper is what I recommend. You guys can do it on an online tablet, whatever. But on paper, I feel like works the best for me. But it's up to you guys. Or just make your own test cases somehow, right? Okay, so step three. So after you guys come up with a solution, right? Don't be like super excited, be like, oh wow, I'm gonna jump straight into coding, right? There's like, sorry, there's like one, I guess, intermediate step, which is step three, right? That you guys have to do, right? So I don't want you guys to immediately jump into coding after you find a solution, right? I want you guys to write something called pseudocode, right? And I guess pseudocode, I did kind of misspeak when I talked about like pseudocode. You have to do, you don't technically, okay, technically you don't have to do pseudocode for everything, right? Only when the solutions start to get complex, right? For you guys right now, I recommend you guys do pseudocode for everything, right? But as you get better and better and better, right? You guys will like be good enough so you guys don't have to write pseudocode for every problem, right? When a problem gets more complex, right, and you know the problem is probably going to be complex, right, then is when you start writing pseudocode. Because some problems, like really, like when you get good enough, you'll read a problem and be like, oh, wait, I can just do this like two lines. Then you don't have to waste your time with pseudocode, right? But when there's like many steps to a problem, and you know that, hey, when I'm coding, I just want to worry about writing correct code than just saying, hey, I have to write the correct code as well as do the same steps to do my solution, right? If you guys just want to worry about one thing at a time, right, write pseudocode. Pseudocode will help you a bunch, right? And it's up to you guys if you want to write pseudocode or not. But for me, pseudocode is very helpful and it will help you find the problem, right? It will, sorry, not find the problem. It will help you code the solution, right? Because now, let's say I have a solution in my mind already. I know what I want to do. I just need my brain follows step 1, 2, 3, 4, 5, 6, blah, 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 right? And it could solve the problem, right? That is my solution, right? But now, right, don't jump in straight into coding unless you know the problem is very easy and you can solve it, right? Just watch out because sometimes you might get too excited and you're being like, wow, this is so easy, right? And then you start like writing code and then you kind of forget about your solution and then you like start all over again and waste a bunch of time, right? That is why pseudocode is important, right? Because you want to have all your ideas down on a piece of paper, down on a solid thing, so you can just follow the steps, right? It's kind of like following a recipe when you're writing your code, right? So I strongly recommend you guys right now write pseudocode, okay? Write pseudocode, it's very important, right? So after you guys come up with a solution, right, write pseudocode. Well, how exactly do you write pseudocode, right? So pseudocode is one thing, right? It is one thing. It's something that you can customize yourself, right? I try to teach you guys my way of writing pseudocode, and well, not really my way. My way, like I just try to make it as efficient and as easy to understand as possible, right? So pseudocode, you don't have to follow my directions, right? But I just gave you guys like a general outline on how to write pseudocode and how you can write, in my opinion, more efficient pseudocode, right? Because you can write pseudocode however you want, right? But there's methods to make it so your pseudocode will write, you can write it fast, right? And that is what sometimes you want for problems. If you guys want to like solve, let's say you want to solve a problem under 1 hour or something, right? You want to be able to write your pseudocode fast, right? So you can start coding and have more time to figure out the solution, right? So, for example, there's some three ways to write it, right? This is my, I guess, my like version of writing pseudocode, and it's a version that I recommend to you guys, right? You guys don't have to do it if you guys don't want to. You think it's not a fit for you. Of course, always welcome. You're always welcome to develop your own pseudocode, right? You can use it as inspiration, or you can do your own. You can use it completely. It's up to you, right? Whatever works for you, right? So one thing I always like to recommend you guys, not recommend, to remind you guys is pseudocode is not real code, right? Like sometimes I see you guys like write, like when I tell you guys to write pseudocode, just write the real code, right? In my opinion, then that means like you're kind of not writing pseudocode anymore. You're just writing the code, right? Because like the goal of pseudocode is for you guys to be able to not worry about writing correct code and writing the step-by-step solution at the same time, right? Pseudocode is able to make it so you write your step-by-step solution, and when you're coding, you only have to worry about writing the code, right? Writing the working code that will mimic your guideline, your skeleton, right? So like that is one, I guess, like thing that I just strongly recommend you guys when you're writing pseudocode. The word pseudo means like fake, kind of. You're writing fake code, right? The code itself won't work, right? But it's like a guideline for you, right? You could, instead of like for I in range, you can just write a for loop, right? For loop A to B or something, right? It's like a fake code just so it's easy for you guys to write real code, because all you have to do is just follow the steps now, right? Because it's hard for you guys to follow the steps in your mind, right? And your problem, your solution in your mind, right, sometimes might have multiple levels to be achieved with real code, right? So pseudocode is technically, it's like fake code. It's not real code. It's not like, for I in range has to be written like for I in range, right? A for loop just might be written as like simple, for like the letters FOR, right? It can be any way that you guys want, right? But I guess like the reason, and again, the reason behind it is so you guys can have a skeleton of your code, right? And then when you're writing code, you can follow the skeleton and write code that actually, is real code, right? So it's supposed to like summarize your ideas as well, right? Summarize your ideas, so then it gets very specific, very concrete on how to solve the problem, right? And again, doesn't have to be real code, right? Some parts, if you really want, you can write it as real code, but at the end of the day, it's supposed to be a skeleton for your code, right? Skeleton just means something to help you write the code. It's not the actual code, right? And if you guys just want to dive into the code, sure, go for it. Just you guys might be at risk of solving the wrong problem or forgetting something about your solution and be like, hey, why does this work? I did everything, right? But in reality, you didn't, right? So pseudocode is very important. So then you don't have to worry about two things at once. You just worry about one thing at once, right? Which is the one thing at once is just getting your solution down step by step, just so it follows your idea in a way that a code can too, right? So yeah, of course. If you guys do have to leave early, hey, no worries. I'll post the recording as well at the end of the class, and you guys did amazing. Okay, you guys did amazing, right? Okay, so let's talk about step three, right? Step three, how is a good way to write pseudocode? What is a good way to write pseudocode, right? And what we talked about, I already posted, how we write, like specifically, how we write pseudocode, some examples. We already posted that in the slides, right? But for here, I just want to give you guys like some more tips, right? Because when problems get more complicated, right, especially even with like binary search problems or some problems, right, sometimes you guys might have like things that you guys have to check, right? You guys have to check for some things, right? And for example, then is when you guys will utilize functions, right? We learned about functions in module one, right? And sometimes we can say like, hey, step A, let's say for example, we want to run a while loop until some check function is false, right? And the check function might be something very complicated, right? It might be like the check function might be like, let's say like we want to loop through the list until I don't know, like all the numbers in the list are prime or something, right? And then like we're doing something to the list, right? We're gonna loop through the list until all the numbers are prime. Well, then all we can do is in the pseudocode, I recommend you guys just do like, hey, um, while check x true or something like that. But this won't work in real code, but like, hey, while check x true. And now I don't know what check x is, right? So on the side, I will label check x. Check x. Right? Check x is, go through x. Let's say x is the list that we pass in, right? Go through list x, check all prime. And here, let me give myself sorry, that's some bad handwriting, but hopefully you guys can bear with me here, right? Go through list X, check all prime, right? So, is it like a select tool that I can move my thing? Oh, oops. Select maybe. And like select everything. Okay, okay. Let me give myself some more space. And like we can like if, all prime. Sorry, it's like kind of bad spacing that would like return true or something. Otherwise, we return false. You see like here, like this is, in my opinion, this pseudocode makes sense to me, right? You guys might interpret it differently. You guys might want to write it differently, but in my opinion, you can see that, hey, now we have a skeleton of our code. Well, check is true, right? And I'm like, hey, I don't have to write all this in here, right? That's like too complex, too ugly to write, right? So you can be like, hey, well, check is true. I can define check x, right? I want to go through all the list. I want to go through list x, check all prime. If it's all prime, we return true, otherwise we return false, right? And this is what check x will return true or false, right? So like, it's just like some method to write pseudocode when you guys get into more complex problems and you guys need something like this. That is one method I recommend you guys write, right? So that is one reason, right? And again, it might be used for harder binary search problems because sometimes you might define made differently depending on something if something's true or false, right? So and like you might like and you might like change your balance based on this other function, right? So you know that is just one way how you write pseudocode, and more specifics are we'll get into it later, well not later but in the past, it was like class 8, class 9, right? The recording's already posted, so you guys can refer back to that if you guys want, but here's just like a more generalized version and another tip that you guys can follow, right? So and again, here's an example, right? And again, you don't have to follow this example, directly, like exactly, right? But you guys can just take this example as inspiration and, maybe even develop your own pseudocode, right? And you can write pseudocodes in many, many different ways, right? But it's supposed to be a way to help you, right? Whatever helps you best, right? So, and step 4, awesome. Once you finish your pseudocode, you can follow your pseudocode and just write your solution with code, right? So that is step 4, remember? Okay, so that is step 4, right? Step 4, there's 4 steps or 4-step process to problem solving. Step 1, read the problem very carefully, right? Step 2, we want to go over every single test case given to us. If we don't have a solution yet, we want to make our own test cases and find the solution. Step 3, right? Step 3, right? We want to we did not do a problem yet. We're just going through like a review on everything we did. Yeah. Okay. So step 3, right? All we do is we just write the pseudocode, right? And then step 4, right? Once we have our pseudocode, we follow our pseudocode and then we write the actual code, right? Cool. Okay. So do you guys have any questions about our steps 1 through 4? Right? Any questions so far, or are we okay? And remember, you guys always, feel free to ask me any questions you guys want. If there's no questions, then we can move on to binary search. No questions? Okay. Binary search, right? So binary search is the only algorithm we learn in this class, right? And the reason is because I guess the things we have to go over with, right? If we want to go over another algorithm, right, we have to do problems on a bunch of problems, and then for this 10-week span of this module, right? I don't think it would have been enough to go over another problem, right? Or not another problem, another algorithm, right? So just give me a second. Sorry. What you talk a lot, like I forget to kind of drop. But no worries. Okay, so binary search, right? This is the only algorithm we learned in this class. And in my opinion, it's one of the most fun algorithms. And it's very fun. It's very smart, right? And it's very powerful algorithm, right? Because in a sorted list, we could basically find something in like, many times less time, right? So binary search, it's a way to search for something, but only in a sorted list, or at least organized in some way, right? The list has to be organized. That means I know that, if I'm here, everything to the left of me is smaller than or something, everything to the right of me is bigger than or something, right? Somewhat, it's in an organized fashion, right? So, sorry about that. So we use this algorithm to find something, right? To find a value, find something in a list, things like that. We want to find something, right? It's something called a search algorithm. You're searching for something, right? So binary search has three things, right? And the three things is you have a middle pointer, you have a left pointer, and you have a right pointer, right? Those are the three things. And here's an idea. It's a big paragraph, but I'll just explain it to you guys in general terms, right? So when we say something's organized, right? If I'm at this value, right, every value, I guess like below me to the left of me, right, will be, right, will be, you know, like all less than me, right? They'll all be, decreasingly less than me, and then every value to the bigger than me would be increasingly bigger than me. And when I say less than or bigger than, it doesn't. There's always cases. There's always like other ways you could like interpret less than or greater than. Some problems might, say like it could get weird sometimes, right? It doesn't always have to be like, hey, less than as in like 5, 4, 3, 2, 1, right? Like or more than like 5, 6, 7, 8, 9, right? There's for now, I guess just think of it as that, but there's always other like methods that they can do. It might be like there's like other classifications of numbers in comparison to each other, right? That's a little complicated. Just don't worry about that for now, right? We just know that it's organized. It's organized. So that means that when I have a middle pointer, my middle pointer will always be between my left pointer and my right pointer, right? So the middle pointer technically splits our search range, which is from the left pointer to the right pointer, right? Our search range in two, right? And every single time we can cut our search range in half, right? And how does that work? Well, let's say for example, we want to find let me make a list for you. Say 1, 2, 3, 4, 5. I want to search for, let's say target is T. I want to search for 2. Say I want to search for 2, right? And can you guys tell me, is this thing organized or sorted in a sense? Is it organized? Is it sorted? Things like that. Just want to let me know. Is this organized? Is it sorted? Yeah, it is organized and it's sorted, right? It's sorted. It's sorted in increasing order, right? So that means when it's sorted in increasing order, if I'm on a value, every value like to the left of me, right, will always be less than me, and every value to the right of me will always be bigger than me. Does that make sense? In a sorted list, right? For this list, for sorted lists, right? Let me repeat that again, right? Like if let's say I'm on 3, right? I'm on this current value. Everything to the left of me will be less than me, right? Will be less than 3, and everything to the right of 3 will be greater than 3, right? Because the list is organized, right? Okay. So for example, we want to find the value 2, right? And let me change the color to something like green so we can label that 2 right here, right? And then let me put another color so we can label the indexes, right? And our left pointer and our right pointer is something you just have to memorize. We want our search range to be the whole list, you know, at the start, right? So that means our left pointer, let's say, will be 0, and our right pointer will be the length of the list minus 1, right? And that's something, again, you just have to understand why is it the length of the list minus 1? Because we know that the length of the list is how many values are inside the list, right? Length of the list is how many values are inside the list, right? And we know that since it starts at 0, like the index will only go up to the how many values inside the list minus 1, right? So this will be the length of the list minus 1, but just so because we already labeled it, we know the value. Say it's 4, right? Because 4 is the length of the list minus 1, 4 for this, right? So now this is the start, right? Our left range and the right range, right? That is the entire list. right? We first start our search range for the entire list, right? And then middle is always calculated as between the left and the right, right? The value between the left and the right, right? So let's just say our middle, what's 0 plus 4 divided by 2? It's 2, right? Because um, we want it to be between, right? The left and the right, right? So this is where mid is. Mid is right here. Mid is right here right now, right? So we will always we're always going to change our bounds based on the value of mid, right? Because we know that, for example, okay, let's say our target is to the left of mid, right? Let's just say that. Our target to the left of mid, that means, our mid value is bigger than target, right? Does that kind of make sense? If our target is less than mid, that means our mid value is bigger than the target, right? If our target is less than mid, then mid is bigger than our target, right? That makes sense, right? Hopefully that makes sense, right? So, okay, so let me guys ask you a question, right? This is the intuition that you guys have to build, right? If our target is less than mid in a sorted list that's increasing, right? Is it possible for our value, our value member is less than middle, right? It's less than the mid value, so it's less than m where I just labeled, right? Is it possible for it to be to the right of m? Is that possible? Right? We just said that our value is less than m. So is it possible for it to be to the right of it? Is that possible in this sorted list? And this is like the intuition you guys try to understand. No, right? Definitely not. Right? Definitely not. Right? And why? Well, because we just said in a sorted list, right? Whatever to the right of me is going to be bigger than me. Whatever to the left of me is going to be smaller than me. Right? So if I know that our target value, right, is less than mid, it can't be to the right of mid, right? Or else it's not sorted, right? It's not sorted. That's impossible to do with binary search, right? So now what we will do is, because we know that no values to the right of mid is like none of the values to the right of mid is going to be my answer, right? I can cut my search range down in half, right? And what I will do is, because it's also not mid, right? It's also not mid, right? Because so what we will do is we can just make it so then right, we will change the right bound, right? Because L is right here and R is right here right now. We can change the right bound to mid minus one. And why can we do that? Because we know it's not mid and we know it's nothing to the right of mid. So we can just put it as mid minus one, right? Does that make sense? So we already know that our value right now that we're searching for, target is 2, right? Cannot be to the right of mid, right? When I say to the right of mid, I mean to the right of where the mid value is, right? So to the right of the mid value, right? It can't be to the right of it. So I can just cut them all out of my search range, right? And I can just move my R to mid minus 1, right? Because it's not mid, it's not anything to the right of mid, right? So I just close my search range now. Remember, our search range is always between L to R. Right? It's always between L to R, right? So now we just cut it, right? L, R equals to mid minus 1. And this kind of what we said right here, right? So, oops. So now we calculate. So now this value changes, right? Oh, well, L is still 0, but this is 1. And this, well, we haven't calculated yet, right? So now remember, mid is always between L to R, right? And because mid has to be a whole number, we just divide around that, right? You can divide around up, but divide around down. Just make sure that you're always less than R, right? So 0 plus 1 divided by 2 is 0.5. Round down is 0, right? So now mid is actually, L and mid, like the pointers can be in the same position. Like you don't have to be scared of that. You don't have to be scared of that. So now, right? M is here, right? Now M is here, right? And now we check, okay, well, our mid value right now is 1, right? Our mid value right now is 1, right? And now we check, okay, is 1 greater than 2? 1 is greater than 2, right? So if our mid value, or sorry, our target value is bigger than mid, right? Like, let's say our mid is right here. If our target value is bigger than mid, will it be, is it possible for our answer to be to the left and to the right? Like which one? Where is our answer going to be? If our in this sort of list, right? If our mid is here, right, and our target value is bigger than mid, right? Is it possible for it to be in the range to the right of mid or to the left of mid? Like which way? to the right of mid, right? Exactly. Why? Because well, we know that every value to the right of mid will be bigger than mid. Everything to the left of mid is going to be smaller than mid, right? So well, now all we do is we move left to mid plus one, left to mid plus one, right? Because we know that it's not mid, right? It's not mid, so it has to be to the right of mid, right? It's not mid. It's not anything less than mid. So now we want to move our left pointer to the thing after mid, right? So now we search to the right of mid, right? So does that make sense? Just let me know if it doesn't make sense, okay? So now L and R in the same position. Um, L and R in the same position, right? And then let's see. Now this goes to one, right? Now we calculate the average is one. So now they're all at the same place. But now we check, hey, mid, we find our answer. Boom, we found our answer, right? Because mid's in the position where answers. We found our answer. You see how we only found our answer in two steps, right? I spent a while explaining it, but we found our value in two steps, right? So, and for example, compared to let's say if our thing was here, right, it'll still take us two steps, right? But you can see that if we went through like one by one, one, two, three, four, five, five steps, you might think like, hey, five steps, two steps, same thing. It's only three steps more. But for example, if our list was like, let's say 1 billion numbers, 1 billion numbers, right? We might take 1 billion iterations to find our number, or we can use binary search and find it in, so well, I can't do the math, but maybe like less than 50 times, right? It's like now you can see, okay, 1 billion to 50, that's like much less, right? So whatever 2 to the power of 50 is. But you can see that, now like binary search is very powerful, right? Because every time we cut down our search range in half and half and half, as long as the list is organized or sorted, right? So does binary search kind of make sense how the intuition works? And remember, I really want you guys to build the intuition to the problem, right? I don't want you guys to memorize the code. I want you guys to understand why the code works, right? Why the code works. Right. Okay. So that's everything we learned basically, right? If you guys, any questions so far, or are we okay? Because other than that, that's everything we learned, right? The most important thing is how to solve a problem, and we also learned a little bonus called binary search, right? So that's everything we learned, right? So I hope you guys like learned at least something from this class, right? We were here for a while, so at least you guys hopefully just built the intuition kind of to how to code, and build the intuition to solve some problems and understand binary search a little bit at least, right? So any questions about how binary search works? Any questions about anything? Or are you guys okay? And here's a sample code, right? Sample code from the problem square root of x, right? It might be like little confusing, and I want you guys to try to understand this problem too. If you guys have any questions, just let me know. Okay. Summary. So this is a binary search summary, right? And I want you guys to understand why, not just how the code works. Right? Homework. So now I want to ask you guys a good question. So I know you guys have worked very hard to solve a bunch of problems that I give to you guys. Right? Give me 1 second. Sorry. I know you guys, have already put a lot of effort into solving problems, right? And I did prepare a final for you guys, right? And I'm like kind of on the fence on if I should post it for you guys or not, right? So since there are 6 of you right now, well, I guess 6 of you, there could be a tie, but do you guys want a final or not? And the final, it won't be like a class, but do you guys want a final or not? Not really like a final, just like just some practice problems. No final? Okay. So I already saw a few no's. So I saw, okay, I see like actually I see some yeses and some no's. So I'm guessing that you guys don't want a final. From what I see in the chat. So I guess then I won't give you guys the final. I mean, okay, I guess I won't give you guys the final. Because I saw like a lot of people don't want the final. Okay, and okay, yeah, Booklet is fun, but I unfortunately don't have one prepared. But that is a good idea. Maybe for I guess the next group of people. I guess I can make a booklet as a final, maybe something more fun than just doing a problem. So I won't give you guys a final. You guys are lucky, right? Congratulations. Um, so since it's about five already, right? I guess we could just end it off here today. Then I again like you guys did an amazing job in this class, right? I'm very proud of you guys, for trying the problems, working hard, asking questions, doing the homework, coming to class, right? You guys all amazing. You guys worked very hard to get here, to get to where you are today, right? And I'm sure you guys will do amazing things in the future. Okay, just never feel discouraged. Okay, sometimes it might get challenging, sometimes you might feel frustrated on something, but at the end of the day, just don't feel discouraged, right? Don't get discouraged. You guys are very smart students, right? And I believe in every single one of you guys. Okay. So I just hope that you guys will continue to code, to do computer science, right? To work on Python, to even learn a new language, right? Java, C++. There's many, many languages out there, but Python is just a foundational language that you guys basically everyone should know. And now you guys know it already, right? So you guys are very already like on your way into the computer science world, right? And I really hope you guys, do consider like I guess continuing to do computer science, right? You guys, of course, very smart, right? And computer science will definitely need smart people like you guys, right? So I hope you guys, I guess we can just end it off today, right? Um, I hope you guys enjoyed this entire class, right? If you guys have any suggestions that you think I can make, right? You guys think, maybe some parts were boring, some parts were too hard, let me know, right? And then I can always improve it for the next group of kids. And Anna did give me a good example. So not a good tip on maybe I can do a booklet. Booklets are pretty fun. But I can do a booklet on, I guess, a final for this class, right? But right now, you know, this is, I guess, the end of this class, right? I don't think I'll be seeing you guys next week, unfortunately. But yeah, you guys ever need any, help, any questions about coding things or whatever, hey, feel free to let me know. Feel free to reach out. You guys still have my email and everything, so feel free to reach out, okay? And you guys are amazing, amazing students, amazing smart people, right? And I'm excited to see you guys go to awesome places when you guys get older. Right now, when you guys, do more computer science in the future, and I really hope that you guys actually continue the computer science journey as you get older. Maybe even after this class, right? Maybe starting tomorrow, right? Or starting, after this class, right? So yes. So my email's like my account in the Google in the like as a teacher in the Google Classroom. So you guys can always get my email from there, right? And you guys will do awesome, right? Wherever you guys go. And I hope you guys just continue computer science. Okay. You guys are already on your way from this class. You already learned a lot. And you guys are, already doing amazing. And you guys, still have lots, you guys know a lot and you guys have lots to learn. Right. So I guess we can just end it off today, right? I'll see you guys, maybe in the future sometime. You guys maybe will run into each other when, in some circumstance. I'm not really sure, right? But I just want you guys to know that you guys did an awesome job, right? I'm very proud of you guys, right? And I'll see you guys maybe in some other classes, right? Whatever. Feel free to just reach out to me if you guys need any help or anything on CS, on, what to do for CS, whatever you guys want, right? Okay. So you guys did amazing. I'm proud of all of you guys. And I'll see you guys next time I see you guys, okay? And you guys are free to go if you want. So good job.
Thank you.
Yeah, of course. And Phoebe, do you have any questions or are you okay?
No, no.
Hello. Uh, do you have any